Okay, we're answering this question for Mika on Facebook. She got a question when she was studying on one of the tutoring websites that she didn't know how to answer. So um, I drew up a similar one here. We don't want to have the exact same problems so that I'm not stealing other tutors' works, but this is a similar kind of problem. So m and n are both integers. We know that mn equals 24. Which of the following could be equivalent to m minus n? Okay, um, so here's some good news. If you are a GED student, although this concept, kind of like this big topic area, does come up on the GED, the topic that we're in right now is divisibility, or you might call this number theory. It's like the branch of math that we're looking at right now. Divisibility is a part of number theory. But anyway, there are a few simple divisibility type problems on the GED. You might see words like factor, GCF, greatest common factor. Oh man, I'm having all kinds of typing issues, y'all. So factor, factor ring, prime factorization falls under this. I'm listing out how you might actually see this on the GED. You might see an LCM problem, least common multiple. It comes up even in reducing fraction problems, of all things. They might ask you if a number is prime or composite. Okay, so on the first 5 problems of the GED, you might have a question that falls into one of these divisibility theories that I've just listed out here, or divisibility types of problems. They're the simpler versions of what we're about to look at. This particular problem is a little more complex than what we usually see on the GED, but it's still useful and the skills in it are still apply. So I'm going to go ahead and look at this problem and work it, even though, like I said, it's probably a greater complexity than what you might see on the GED. Okay, so m and n are both integers. The first thing you have got to understand is what the word integer means. That's really the key to being able to work this problem. Okay, so if I say that a number is an integer, integers are defined as the set of whole numbers. Well, what in the world are whole numbers? Whole numbers are our regular old counting numbers that we used from the time that we were first learning math. I mean, what was the very first thing you learned to do, right? Your mom set you down with your blocks and you started counting blocks. That's what you did as a little kid. And, you would count 0. Well, you wouldn't say 0, would you? Let's be truthful. You probably started 1, 2, 3, 4, 5. Those are the counting or natural numbers. But then the second you throw 0 in, we're talking whole numbers, okay? So if I say the set of whole numbers, that's like 0, 1, 2, so on and so forth. Now, this is not all of this definition, though. But let's just talk a little bit about these whole numbers. You and I know that, when you were a little kid, you thought it was really amazing to be able to count to 10. You got a little older, you could count to 100. And now we know that there's really no end to this. This set of numbers goes on and on forever. We could keep counting until the end of time. Okay? So integers, the set of whole numbers, but we're missing half of the definition. And their opposites. So what would be the opposite of all these numbers? Well, the exact same numbers that we're seeing here, but with negative signs on them. So now that would go off in the opposite direction for forever. Like there's the negatives of all the ones we saw up there. We have the opposite of 1, which is -1, and the opposite of 2, which is -2, -3, so on and so forth. But as we know, the negatives could go off forever. So that's the idea of integers. The main thing about integers is that they have no pieces or parts. So we're not talking decimals. We're not talking fractions. We're talking only whole numbers. And that was the clue for me to know that this was a divisibility problem, because I'm basically asking, when I say m times n, see this, it says we know that mn equals 24. I hope you know, we definitely do have to know this for the GED or any really algebra class. I mean, this is just basic. We had better know that when two symbols are pretty much shoved together, so whether it's a number and a letter or two letters, I need more room. I need more room. Yeah, when two numbers are shoved together, they appear to have no operation in between them. You can, let me say two numbers. Not two digits now, but two numbers are shoved together with nothing between them. You can assume they're multiplying. I have a joke for this. I'm like, seriously, guys, if you see two people up on a street corner all shoved up close to each other, they're like, hey, all pressed up real tight, you say to yourself, those two have been multiplying. So same thing here in the number world. If you get two things shoved up real close together, you can't tell what they're doing, just assume multiplication. So what they're saying here is that m times n equals 24. And so I know that there's only a few ways to multiply to make 24. Those are known as the factor pairs of 24, the different ways to multiply to make 24 with whole numbers. I could use 1 and 24. I could use 2 and 12, 2 times 12, 3 times 8, and I'm just working my way through factors. If you don't know how to do this, check out my Finding All Factors video. Okay, I have a video on this. But here's all my possible options, factor pairs now. It must be one of these sets of numbers to get to 24. Now, some of you guys who are a little more advanced in math could realize that it could also be the negatives. Like -1 and -24 would also multiply to make 24 if they were both negative. So this is a little more complex than we need for this problem, but you should be able to recognize that it could be all these same sets of numbers, but totally negative, because when you multiply two negatives, it makes a positive. Okay, so there's all my possible ways that I could have used integers in order to get to 24. Now I'm looking for which one of these, if, let me start again. Whoa. Let's read the final question. Look what I'm looking for. It says, which of the following could be equivalent to m minus n? So the idea here is I'll take the factor pair and I'll subtract them. Well, let's think about it. If I subtracted here, like 1 minus 24, I would get negative 23. Or I could do it the other way around. 24 minus 1 is 23. That is not from my list. Okay, but one of these does have an option on my list. So basically, let me write down what I was doing in my head here. I was just subtracting this both ways. I was saying, okay, if I subtracted them that way, 1 minus 24, I would get negative 23. Or if I subtracted them the other way, 24 minus 1, I'd get positive 23. Either way, not one of the numbers in this list up here. But one of these I do see. Take a look at this factor pair, 3 and 8. A lot of you could see pretty simply that if I took 8 minus 3, I would certainly get 5, which is on this list. Now, the good news is you're like, why didn't you try every single one of these pairs? I don't have to. It says which of the following could be equivalent to m minus n. All of these could be an answer. I could subtract all of these and I could come up with, let's see, 2 answers for this one, 4, 6, 8, 10, 12, 14, 16. There's 16 possible answers here to this problem. I mean, just counting this way. I am not going to subtract 16 times. The second I find one that could be true, I'm going to call myself done. Okay, awesome. So that's the answer to this problem. Again, if you have any math problems that you just don't know how to answer, y'all know I have no life. All I like to do is answer math questions all day long. So drop them on my YouTube channel or drop them on my Light and Salt Facebook page, and we'll see if I can make them make sense.